Hello everybody and welcome back. So today we're going to be talking about something called regular expressions. So if you've done any coding before, you may have come across this term, maybe you've even used them before. Today we're going to be looking at how to use them in VEX. So what is a regular expression? So a regular expression is basically a string of symbols that represents a pattern to search for within a string. Okay, so it's kind of like a much more complex way of using wildcards, where you have a star means, anything, like any characters, and then there's the caret, sort of the upwards arrow symbol that says an exception. It's like that, but it's much more powerful, and you can do loads of things with it. You can group sections of the string and match and search and count how many times you find that. So we're going to be exploring how to use this in VEX, and if you can do this, this is fantastic. It just opens up a whole world of possibilities whenever it comes to analyzing a string and extracting the right data that you need from it. Okay, so there's a few resources we're going to be using today. In my scene, I just have a basic grid, and then I've got a few attribute wrangles set up with a few snippets of code just to help us test really quickly. Okay, test the four main functions, and there are four main functions in VEX with regex. Okay, regex is like the nickname or regex for regular expressions. So you may hear me use that quite a bit. So I'm just going to be working through these four functions. So we'll do them in order, one wrangle for each. Okay. There are a lot more functions. Also, I'm not going to be talking about the split because we won't really use that. But if you use something like Python or another coding language, there are much more detailed expressions that can be used in regular expressions. But VEX just uses these four, and then they'll be plenty enough. Okay. So this is what we're going to be using, and then the other resource you're going to want is this website. I'm sure there are others that do something similar, but this one is fantastic. So it's called Regex 101 or Regex 101, however you want to pronounce that. And it's essentially a test website. Like it lets you test your regular expression, and it's got a very cool way of sort of showing you what information your regular expression is actually grabbing from that string. And it lets you test it in all the different languages as well, because there's some slight different syntax with all the different expressions. And it's got a quick reference here, so it actually simultaneously teaches you how to use it and lets you test it. Okay, so we're going to be jumping in and out of this website here to test our string and our regular expression, and then applying that regular expression here within Houdini to see what we can do. Okay, so let's jump in and get started. So and if you're a little lost at this moment, when you start seeing it come together, it'll make a little more sense. So just try to follow along. So the first one we're going to start with is a very, very simple one, and it's a rematch. So essentially what we're doing is we're searching a string to see whether the entire string matches the expression we've given it. Okay, so this is a way of checking a string based on certain conditions to see whether it is valid or not. Okay, but it has to match the entire string. So here I'm just creating a test string, literally called test string, and the result is this sentence. This is a test string, okay, with spaces in between. Okay. Then what I'm doing is I'm creating a regex string. So this will be the pattern that we are going to be searching our input string for, right? So we use this pattern to search in here. So I'm just storing it as a separate string, and then I'm just running the actual rematch. So with regex there and test string there, and then I'm just storing it as an integer so we can see it, because what it returns is an integer. Remember, what it's basically returning is saying yes or no, it either is matching or not. Okay, so The string that I'm going to feed this is going to be a series of symbols which are going to help kind of parse through this string and figure out like whether it matches or not. So it's sort of like wildcards. And then one very important thing to note is you'll see I've got this small like lowercase r in front of the string. Okay. In some cases this is not necessary, but most of the time you're going to want to convert this string to a Python style raw string, okay, in order for this to work, because a lot of the patterns that we want to insert in regular expressions will not work unless this is a raw string, okay, because when it's raw it will not read certain escape characters, and we're using a lot of escape characters as part of the pattern, so we basically need to tell it, okay, ignore those and just read it as a raw string, right? Okay, so let's take this this example. This is a test string, and I'm going to just drop it down in here in Regex 101. Okay, and in here we can start typing, and in fact you'll see even when I'm set to Python, you'll see that it has the lowercase r in front of the quotes here already, so you can see that, you know, that is it's kind of there to remind you to do it, right? So basically, if I type something in here, so if I type the letter A, right, it's going to come up with, it's going to find the A in here, right, within the string. And even if we hover over it, it's going to show you that it's found one match, and then it's put it into sort of a temporary group, and it's telling you the position of the character and what it's found, and on the left over here it'll show you it's found a full match for this character, right? So again, this is why I love this website, because it really helps, and it explains what's happening over here, that it's matching A because it matches this literally, okay, and it is case sensitive, so like it gives you a lot of information, okay. So if you just type any particular things, maybe let's type the word test, or even not the full word, TES, and it will still start finding it within here, okay. So this is one way of sort of using regular expressions, is you can actually give it literal letters and it will find them within the string. Also, if we say IS, now you'll see there's two instances, so there's match 1 and match 2, and it's finding IS because it's at the end of the word this and then also the word is, okay. So this may be what you want. You may be wanting to find all instances of the word is, or you may not want this. So then you have to give it more information about what it should be finding and what it should not. Okay, and this is where we start using symbols to kind of tell it, to denote what we actually want it to do. So let's say we wanted it to only grab, the word this. Okay. So then we need to actually tell it that there is a character before it, or maybe, as it's suggesting here, that that we tell it that it's the start of the string. So you could, obviously you could type the whole word this to then make sure that you would only find that, or you could say that, for example, that it should be preceded by any word character, right, which is a slash and then lowercase w. Okay, so if we put a /w, now it's going to find the H, and we can put another one /w to find the T. Okay, so it'll find the word this, but it'll also find, trying to think of a word. It doesn't matter. You could put XGIS, and it's going to find it because it's finding the X and the G and the T and the H, because this is a replacement for any word character. So I said this is like using your wildcards, like putting a star, right? But in this case, it's a special type of star, because we're specifying, okay, it's anything, but it's not just absolutely anything, it's any word character, right? So what that means is that it will not find, if instead of a G, if it was a dot, then it will not find this here, because it's looking for 2 word characters and then an I and then an S. And this is not a word character. A dot is not a word character, okay? It's a space character or a non-word character. It won't find a slash. It will, however, count underscores. This is important to note that underscores count as word characters, okay? But spaces do not. Spaces count as white space characters, okay? So you can even look in here for any white space character as a /s. So if we did want to find that, then we'd put a /s, and now we'd find x space is, but we'd also even find the s space is over here as well. Okay, so I hope you're starting to see how these are sort of very specific like wildcards, okay? You're specifying that you want to find something, but you're telling it what type you want to find. Whereas there is a dot. So if we use dot in here, in our regular expression, dot is going to find any single character, okay? So we could put a dot in here, and then it would find the word this because it's using a T, and then so that it's finding a word character, T. It's finding any character, the H, and then it's finding the IS. Okay, and it is also finding the X because it's a word character, dot for anything, so it's counting the space as anything, and then an IS. So the dot is kind of like a star with your normal wildcards. And you'll notice that it's not finding this one here, even though it should find the S, the space, and the IS, because the matches do not ever overlap. Once it finds this first match, it extracts this match and then searches. So then it will not find the S space IS because this S has already been extracted. Okay. All right. So don't get overwhelmed and confused. There are other lessons out there if you really wanted to get into using the regular expressions. There's lots of resources to learn it, and there are loads of different expressions you can do within them. We're just going to cover a few, just some very basics, because I don't want you to get overwhelmed and now have to, in the middle of learning Vex, also learn the entire language of regular expressions. Okay, so we're going to go back to our original. This is a test string, right? And so if we hit an I, we're going to find all the I's. And if we put a dot, then that means any character that follows an I, okay? So we're going to be finding an I and an S, okay? And an I and an S and an I and an N, all right? So that's one way that we can search this, and we are going to use this just now. But what we're wanting to do with this, right? Don't forget that we're wanting to match. So we're wanting to match the entire string. So let's say this was a test string that we were receiving, and we wanted to check that it met 2 criteria. One, that it begins with the word this, and that it ends with the word string. But then we don't care what there is in the middle. Okay? So that's what we're going to be typing here. Now, we're going to be using the start of string character, which is a caret, so like that, which in Houdini you're normally used to that being an exception wildcard, but in this case it says the start of a line, right? Now you see it doesn't count the first character, it just denotes that the line begins here, okay? And then the word this, okay? Which means that if we had another sentence where it had something at the beginning and then the word this, it will not find this one. It will only find the one here because it actually is at the beginning of the line. Okay, that's what that caret does for us. Okay, and then we want to say, now I want you to match any number of characters from this point onwards until you find the word string, and then check that the string is at the end of the sentence. Okay, so we're going to say dot because we don't care. We wanted to find white spaces, characters, not like word characters, non-word characters, doesn't matter what. And instead of putting a dot to like keep, selecting more letters, okay, and also we don't know how many there are going to be, So instead we're going to say I want you to find more. So a star tells it to find 0 or more, and then a plus tells it to find 1 or more. Okay, so in this case we don't care if the word string immediately follows the word this, and therefore there is nothing, there are 0 other characters between these two words. Then we still want to say yes, find this string. So then we'd use star. If we insisted that there must be at least one character between the word this and string, then we would use a plus. Okay, so in this case it's going to look exactly the same, but I'll show you where it differs. So dot star, so then it's selecting everything, but then this is not taking into account the second condition, which is that we want it to make sure that we select the word string. Okay, so I'm going to type the word string, and then also we're going to finish it with a $, which is to say the end of the string. Okay, so this will correctly match this, right? But if I have something where it says, okay, this, oh, sorry, let me just change it in here. So if we had to kill all of that, it will still find it. You see, it's still matching. But if this had to be a plus, no match, because there are no characters between here, and we're saying we want to find 1 or more of any character between this and string. Whereas if there was a space, then it will match. Okay. Also, if we're trying to find all of that, but then there's something else after the word string, it will not match at all, because we're saying this must be the end of the sentence. Okay. So it will match what we've currently given it, and will match all these scenarios we specified, where it doesn't matter what is in between, it's going to keep matching it all. Right, so this is what we're wanting to copy. So you can just copy your regular expression, and you're going to insert it here in your match as the expression to search for. And you'll see that the match is returning a 1. Which is exactly what's happening in here. When this goes blue, it's basically saying, yes, I found a full match. Okay. So without that, so for example, we've got the plus. So if we changed this to have nothing in between, then 0, or to have a space in between, it says, yes, I've matched. Okay. So this is doing exactly the same thing as in here, but this is just so much more interactive. It's really nice and fun to see, you know, how it changes, and it tells you exactly what it's doing. So I prefer to use this website and then jump in here and just paste my expression. Now it is good to note that certain patterns that are in regular expressions don't actually work in Vex yet. I haven't figured out all of them which work and don't yet. But there's a lot of help on the forums and things like that, so you can look for that. But if you keep it to the simple ones, then generally they seem to work. Okay, so there's a match where we're checking a string and whether it matches or not, and this needs to match the entire string. So if we have more characters, false. Now we're going to move on to a find all function. So what the find all is going to be doing is finding all of whatever the regex match is within the string and returning it as a string array. Okay, so we're writing out an array of strings, which are basically the matches for here. Okay, so remember I showed you that in here we had a couple of instances of I and then another character. Okay, it's the is the word, then the is at the end of this, and then the in in string, because here we're saying we're matching any character. Also note we could put a /w because we're wanting to match any word character. That would still come up with the same 3 matches. Okay, and if we use that in here, so you'll see it's not matching the full string, so it's not a full match, but we're having a partial match. But find all is going to build an array of all of those partial matches. Okay, and if I hit insert, you'll see here that is finding, and it's building this array of the, is, which is part of this, the is, which is the word on its own, and the in from string. Okay, so this has done exactly what we've wanted it to do. Okay, so just note that this, we're going to get around to groups later when we do the find, but just note that this, it captures and it builds an array, but it doesn't have any actual capture groups. Okay, so this is a very limiting kind of function. It's simple, and it may be exactly what you need, but our find function is going to be much more powerful, so you're probably going to want to use that if you want to do anything other than just extract these words. Okay, so let's move on to something similar but maybe a little bit more functional, is replace. So we've got our same string here, and in fact we're going to feed it the exact same thing that we just did. So I slash and then a lowercase w, right? But what we're feeding it now, so replace is going to basically return a string. It's going to return the new string where we have given it the regex. We've told it what to replace all of the instances of where it's matched with a replacement string, and then we're feeding it the string to search, right? And then we'll get around to this optional argument just now. Okay, and what it's done is it's gone and searched this string for this regular expression pattern, and wherever it has matched, it has replaced it with 2 underscores as I've given it here. Okay, and you'll see in here that is exactly how it's worked. Okay, so I'm sure you can see how this can be very, very useful. And there is this optional maximum replacements as well if you wanted to. So by default it's 0, and when it is set to 0 it will have no maximum, it will just go infinitely. But if we had to set this to 1, then you'll see that it replaces only the first instance of the match. If we replace it with 2, you'll see it will replace 2, but it will not get this far, and then only with 3 will it actually match. Okay, so very powerful for just going and sort of doing a search and replace, which there is a replace function, a string replace in Vex, but regular expressions can search for much more complex wildcards. So if you can figure out that there's a pattern between, like within the string that you're receiving, but it's a very complex pattern, with maybe a very specific number of word characters, even though those word characters are totally different, and each one is preceded by 2 digits and a white space, or some weird pattern that you wouldn't be able to do in normal string replace, regex will be able to handle that. Okay, so we're going to move on to the final one, and this is where it gets a little bit more complex and a lot more powerful and fun. So what I've got is a bit more of a practical example. I've got a path, so in my C drive to some sort of path, and then some file name dot $f3.bgo.sc. Okay, but I want to replace this with, like, let's say we were on whatever frame 4 or something like that. So we were maybe reading it in as an actual file or something like that, and then referencing that file in here. So as our frame number changes, then so would this number. So here's an example of something that we would actually be searching. And what I've got is my regular expression string. And then I'm running kind of all of the different modes of the refind function. Okay, so here it can return an integer of whether it has found a match or not. So this is similar to match, except it doesn't have to be a full match. Then the string version, which is where it actually returns the first substring that it matches. Then there's also a mode here where it can write a start position and end position array for all of the matches that it finds. So I'm creating 2 arrays and writing to those 2 arrays. And then I'm also running this version where it is giving me a string array of all of the matches, okay? And you'll see how that works with our groups. Okay, so I'm going to copy this to our regular expressions, and then we're going to build up the regular expression and then bring it back in here and test it. Okay, so here we have this. Now what I want to do is search through this entire string, and I want to start basically separating it into its separate usable sections, as well as actually checking that it meets certain conditions, right? So the first thing I'm going to want to do is I want to check that it begins with a word character and a colon, because I know that my paths should have, you know, a directory. Okay, so I'm going to put a /w for word character. Now see how many matches it is finding. Right, these are all the word characters, but I want to have a word character followed by a colon. Okay, so that's the first thing I want to search for, but I want to put this in a group, and we grouped here just using round brackets. Okay, you can name your groups if you're using Python, so there's a certain group constructs and stuff where you can actually name the groups and then reference them back later with a group. To my knowledge, this doesn't work in Vex. It won't error out, but you won't be able to access the name of the group anyway. So just using a round bracket is enough. Okay, just for interest, I think it's a $P, and then you put the name of the group inside of here. So this will not error in Vex, but it will just ignore it anyway. Okay, so we're wanting that as one of the matches. Okay, one of the groups is our actual like which drive it's on. Okay, and then that is followed by a /. Okay, now the reason why I haven't included the / in here is because I don't want to include the / in the group. Okay, so I just want to know, you know, that it has the group, and then this / is outside of the group. Okay, and then I want to find a word character. Okay, but I actually want to find any number of word characters. So we could use a star, but that would mean 0 or more, but we don't really want to find a 0 or more. We want to find 1 or more, because we know that we should have at least one character before we hit each /. Okay, if you find that you do sometimes have, you know, //, well then maybe you should use that, because then it will work. So either one will work in this particular case, but just make sure you know the difference between the stars and the pluses. Okay, so we want to find any number of word characters followed by a /. Okay, and we want to group this whole thing, right? So there's one instance of it finding a whole bunch of word characters and then a /, but we want to do the same thing again and again and again. Now I don't want to have to type this whole thing multiple times and go and find it all. Plus, we don't really know how many times, like, you know, the actual, like the depth of our file, how many folders is it inside of, right? So we just want to repeat this. Okay, now we could say repeat it any number of times by just putting a star, which would be 0 or more, or a +, which means 1 or more. But instead what we're going to do, because we want to we know that it's going to be at least 3 deep, but maybe up to 6 deep. All right, and then so we specify that with curly brackets after the group, is we say we're basically going to repeat this between 3 and 6 times, right? So if there are too many folders, it will not find it, but if there's too few, it will not find it. So we're using this as a way to sort of validate this this path. Okay, and I want to contain the entire path, the folder path, in a group as well. right? Because we're using this group over here as a way to just say we're grouping this together so that we can repeat that group 3 to 6 times. But I want the entire result, no matter how long it is, to be grouped. So I'm going to put this entire thing in brackets as well. Okay, so you see here, this group 2 is what I really want. So I'm wanting this group 1, and so the drive, I want the path, and then I also want the file name. All right, so the file name we're going to put in brackets, and that one's easy. So any number of word characters. Okay, well, maybe we'll just do plus because, you know, there's clearly going to be something. If there's no file name, then we've got a problem. So actually we need at least one character. Okay, and remember, because underscores count as word characters, that's why it's so easy to just kind of put this all in one and encapsulate that entire thing in one group. Now we know that because it should have a dot and then a frame number. Well, we don't know what that frame number is going to be. So we can include the dot. And then obviously I want to extract my frame number as a group. So in brackets, I'm going to put, like we would put 004, and then that would work. But instead, we want to replace this with 3 digits. Okay, so we can use similar techniques to what we've used here. You'll find in this list that slash and a lowercase d is for a digit. So it's finding 1 digit, but I want to tell it, well, find 3 digits, specifically 3, no more, no less, right? So then in curly brackets, I'm going to put 3. So then you see it says there that it matches exactly 3 times. Okay, so there we go. Now it doesn't matter if it's frame 4, frame 8, frame 12, it's going to keep finding 3 digits, right? And then we might want to encapsulate the entire rest of this, including the first dot, because that is the file extension, so .bgo.sc. Okay, if you didn't want to include the next dot, then you would just put it there and then start your group. So you can do it either way. It depends what you want. And then we know that we want basically the rest of it, because we don't know, maybe they feed it a different extension. So we don't want to specify that it must be .bgo.sc. Well, I don't want to in this case. If you know that you specifically want to search for .bgo.sc, then do so. Then you can just type it literally. But here I want to just select basically all the rest of the characters, up to the end of the string. Okay. In fact, we'll make sure that we put a dollar sign to show that I want to make sure that I keep selecting all these valid characters and that it goes all the way to the end of the string. So if there's something at the end that causes this whole thing to break and not reach the end, then it will not return a match. Okay, so you see how this list of sort of patterns and expressions has returned us the drive, the path, okay, you'll see here what it's doing, because we're looping here 3 to 6 times. It will return the last one that it has found as group 3. Okay, because group 3, this group, is being replaced by the word sum, and then replaced by sort, and then replaced by of, and then replaced by path, and then it stops. So that's why we have a group that has path in it. Okay, you'll see it'll do the same thing in Vex. Then we have our file name, we have our frame number, and we have our extension. You see the power of this to be able to check that something matches and extract it into different usable sections, all within one pattern. So we're going to copy this, and we're going to dump this into our regex over here and have a look at what Houdini has done. So see here this string array, which I've just called array, with the find, okay, has returned pretty much what we've got going on here, right? So it returns the full match, it returns our drive, the folder, then that last folder found in group 3, then the file, the frame number, and the extension, right? And these are all elements in an array, so we would be able to go and extract from that array like we've been working with. There's also an end and a start array, and these are showing for each one of these matches that it is found in here, so for example, the first one, where does this full match start? It starts on the first character, so 0, and it ends on the 46th character right at the end. Where does this one start and end? It starts on 0 and it ends on 2. Okay, where does this one end? Starts on 3, ends on 21. So you see, we can even use this to go back to the original one and extract certain sections. Okay, or create substrings. We can do a whole lot of things with these two arrays and then this one. Okay, and then it is also returning I, which is from here, a match of whether it matched correctly or not. So 0 or 1, and it's returning the match in S if it has found it. So these are a whole lot of different ways to use the find function. Okay, you normally wouldn't need to use all of them in one go, because if you're going to be building this string array over here, then you wouldn't need to check whether it succeeded or not, or take the full match in here, because this will be returning the full match here. And if the length of the array is 0, then it has failed. So I wouldn't run these first two, but definitely worth feeding it these two arrays where it can store your start and ends. Okay, and in fact, you shouldn't have to. I don't believe you should have to. Oh no, you do. You do have to, because I was thinking you could probably put the start and end array as arguments inside of this mode, but it doesn't look like you can. I think you have to run this separately. You can specify where it starts and ends, but here this is different. Here you're able to give it a start position and end position array for it to write into. So I think you'd have to run both of these two. So I would cancel these two lines. Because you don't really need them, but these two I would run in order to then figure out exactly my start array, end array, and my full match array. Okay, so I hope this is making sense, guys. Like I said, there's a lot of resources to learn more about regular expressions if you feel like you need to know more about them, and there's a lot of forums that help. I would really recommend using this website to test and practice and learn regular expressions. And they are absurdly powerful if you know how to use them. So I'm sure you'll come across scenarios where it is beneficial. Right. So I hope you guys have followed and enjoyed that lesson, and I look forward to seeing you in the next one.